And our Daytime on 2 continues with part 3 of statistics in our series, Maths Topics.
This program has been designed mainly for recorded use. Full details are in the notes for teachers. Somewhere down there is what is sometimes called the average man and the average woman. But where and who? And average what? Well, for example, average height. But what exactly do we mean by average height? And who wants to know? Furniture manufacturers, for one. This chair will fit someone of average height, if they're about 5 years old. The manufacturers of these chairs and tables need to know the average height of a 5-year-old child. An organization selling clothes in large quantities tries to be sure that it has enough of each size to fit most people. Clothes are made in various sizes to suit us, the people who will buy them. And when you're dealing with these sorts of quantities, you've got to be as sure as you can that you've got the sizes right. For instance, before putting these tops out for sale, the store wants to know the sizes of the girls and women who are likely to buy them. These jeans are likely to be bought by teenage boys of 15 or over. So what is known about, let's say, the height of people aged 15? To help us, we enlisted all the fourth-year pupils of this school in North London. Altogether, there were 113 pupils in the fourth year, and after finding their height to the nearest centimetre, we first of all divided them up into groups with 5-centimetre intervals. Seven pupils were between 150 and 154 centimetres tall, 7 between 155 and 159 centimetres tall, and so on. We can represent this data as a histogram. The most popular height is 170 to 174 centimetres, with 30 of the pupils. Would this be true for a population of just one sex, say boys? Let's find out. For the boys only, the most popular height, or rather interval of height, is still 170 to 174 centimetres. This is the modal class. This time, the boys are arranged with 10-centimetre class intervals. Now, the modal class is 170 to 179 centimetres. So, modal class, as a measure of average, depends on the class interval. This time, the class interval is just 3 centimetres. Here's the corresponding histogram. And now, the modal class is 168 to 170 centimetres. But modal class, or mode, is only one kind of average. This time, we asked the boys to arrange themselves in order of increasing height. With the boys arranged in this way, you could say that the average height is the height of the boy in the middle of the line. He's the one with 31 boys on either side of him. His height is 169 centimeters. This kind of average is called the median, and it's not the same as the mode. But mode and median are not the only kinds of average. There's one more commonly used average. But to find this, we would have to chop bits off some of the boys and add them to the others. So we've decided not to do it for real. Take 8 boys as an example, with a column to represent the height of each boy. Now, if you were able, you could redistribute the boys so each had the same share of the total height. Then the height they would all become is 172 centimeters, which is the mean height, or just the mean. Of course, this only works for numbers and not real people. You may or may not find that at least one of the people has the mean height. We can get just the same for the girls, although of course the actual values may be different. But from the point of view of clothes shops, the mode is most useful, because that describes the most common height. If these girls went into a shop, it would be clothes to fit the modal class that would be most in demand. Shops stock and sell more of the mode than any other size. Of course, the other girls will also want to buy clothes, so the shop has to know the distribution of sizes, how many of each size it should stock. So what spread of sizes should the shop have? What are the biggest and smallest sizes it will need? This time, we asked the fourth-year girls to line up in order of increasing height. Our smallest girl is 149 centimeters. The tallest is 172 centimeters. So the range of sizes is 149 to 172 centimeters. But the range is not a particularly useful measure of spread. There are only a few girls at the two extremes of the range. Most of the girls are in the middle. Clothes shops might decide that it's not worth their while to carry stock for the few people on the extremes of the range. But where do they draw the line? Let's use this histogram, here's a small copy of it, to create a new type of graph in which we plot the number of people up to a certain height. The histogram shows 3 people with height up to 154 centimeters. We'll put them in the new graph. The people with heights up to 159 centimeters are in the first and second columns of the histogram, which together will represent by a single column on the new graph. The first 3 columns of the histogram together show all the people up to 164 centimeters, which again was represented by a single column on the new graph, and so on. Normally, we draw a line through the tops of the columns to get the cumulative frequency graph of the sample. If we had taken several thousand girls in our sample and used smaller class intervals, then we would have got this much smoother cumulative frequency graph. In these circumstances, the vertical axis is usually measured in proportion. What can a graph like this tell us? First of all, it can tell us that the median, the girl in the middle of the line, is 163 centimeters tall. We can also find the height of the girl a quarter of the way along the line, and 3/4 of the way along. And from this, we obtain a second measure of spread, the interquartile range. Half the girls, the middle half, have heights in the range 158 centimeters to 168 centimeters. We can now describe the girls' heights in our sample by the median and interquartile range. The median height is 163 centimeters. The interquartile range, the heights of the middle half of the sample, is 158 to 168 centimeters. Unfortunately, even interquartile range is not a particularly good measure of spread for the clothes shop because it excludes as many girls as it includes. Better measures can be obtained using smaller intervals than quarters. Why not tenths? Or percentages? Now we can talk about the middle 50%. Or the middle 75%. Or even the middle 90%. The middle 90% is a good measure for clothes shops because it includes most of the girls and yet excludes those on the extremes of the range whose heights are very different. Now let's look at a different way of measuring spread. First, find the mean, which for our girls is 166 centimeters. For the first column, the middle is at 152.5 centimeters, which differs from the mean by 13.5 centimeters. We call this difference the deviation. There are 3 girls represented by this column, so the total deviation, obtained by multiplying the 2 numbers, is 40.5 centimeters. The middle of the next column deviates from the mean by 8.5 centimeters. The column represents 6 girls, and so the total deviation for them is 6 times 8.5, which is 51 centimeters. And so on. The total value of deviations from the mean is 269 centimeters, and there are 50 girls. So, on average, each girl deviates from the mean by 5.38 centimeters. This is known as the mean deviation. So, just like average, there's not one measure of spread, but several. A knowledge of average and spread helps the clothes shop to decide what to stock. The shop has sizes to cover, say, 90% of the range, having decided it's not practical to cover the extremes. But there's one important aspect we haven't looked at yet. The size for clothes isn't governed by height alone. Our modal class of boys, that's the longest column, are all nearly the same height. But do they have the same build? Not necessarily. Their chest sizes, arm lengths, and other physical characteristics may be quite different. This shirt is made the right length to fit the boys in our modal class. But how long should the arm be? How big should the collar be? These other physical characteristics also have a spread. For instance, from a larger sample of boys, all with the same average height, we found that the range of chest sizes was 87 to 117 centimeters. Using the cumulative frequency graph, the manufacturers might decide to cater for 90% of this range. All all clothes sizes are determined by the ranges of all physical characteristics. Normally, they're made to cover 90% of each range. So a knowledge of measures of average and range is vital to the making and selling of clothes. And sometimes that knowledge can produce some unexpected results. For instance, this store stocks a range of sizes based on the physical characteristics of people in the south of England. Our pupils came from a school in the south of England. But if we'd chosen the school in the north of England or Scotland, then our histogram could have been rather different. And what ranges of sizes would a shop stock if it only sold fashion clothes to young, slim girls? So next time you hear about average and spread, ask yourself which average and which spread are they talking about. But remember that no normal measure of average and spread can account for everything. Some things always fall outside the normal spread.
Well, we're just about 5 minutes away from a bit of fishing in Words and Pictures.